Hello friends, now we see the problem 4 of question 4, which is also based on theorem of parametric function of chapter differentiation. The sub question 4 is differentiate tan inverse in bracket square root of 1 plus x square minus 1 whole thing divided by x with respect to tan inverse in bracket 2x into root 1 minus x square whole thing divided by 1 minus 2x square at x is equal to 0. Now let's see the solution. First of all, the first function we denote as a u and second function we denote as a v. So let u is equal to tan inverse in bracket under root 1 plus x square minus 1 whole thing divided by x, and v is equal to tan inverse in bracket 2x into root 1 minus x square whole thing divided by 1 minus 2x square bracket complete. So in this case we have to find du upon dv question mark at x is equal to 0. So that is our question. So first of all we start from u. Since u is equal to tan inverse in bracket under root 1 plus x square minus 1 whole thing divided by x. Now here we put x equal to tan theta, we get therefore theta is equal to tan inverse of x. So the next step will be u equal to tan inverse in bracket under root 1 plus tan square theta minus 1 whole thing divided by tan theta. Now 1 plus tan square theta is an identity which gives us sec square theta. So therefore u is equal to tan inverse in bracket square root of sec square theta minus 1 upon tan theta. Therefore u is equal to tan inverse in bracket. Now square and square root cancel, so we get only sec theta minus 1 upon tan theta. So u is equal to tan inverse of. Now for sec theta we write 1 upon cos theta minus 1 can be written as 1 upon 1 whole thing divided by. Now for tan theta we write sin theta upon cos theta and the whole bracket complete. Therefore u is equal to tan inverse in bracket. Now in numerator we go for cross multiply, so we get 1 minus cos theta upon cos theta, then into now sin theta upon cos theta. If we take in numerator, so we get cos theta upon sin theta and then bracket complete. So u is equal to tan inverse in bracket. Now we cancel cos theta from numerator and denominator. So we have 1 minus cos theta upon sin theta, the bracket complete. Therefore, u is equal to tan inverse in bracket. Now 1 minus cos theta is equal to 2 sine square theta by 2, and whole thing divided by, for sine theta we apply formula of sine 2 theta, which gives 2 sine theta cos theta. Therefore, for sine theta we write it as 2 sine theta upon 2 into cos theta upon 2. Since 1 minus cos of 2 theta gives 2 sine square theta, and sine of 2 theta is 2 sine theta cos theta. Now here we cancel 2 from numerator and denominator. At the same time, sine theta by 2 from numerator and denominator. So we left with u is equal to tan inverse in bracket sine theta by 2 upon cos theta by 2. Therefore, u equal to tan inverse in bracket sine upon cos, we get tan. So therefore, here we get tan of theta by 2. Now cancelling tan and tan inverse, so we get u is equal to theta by 2. So now theta we replace tan inverse x. So u is equal to tan inverse of x upon 2. So in this way we simplified the first term. Now differentiate u with respect to x. So we get du upon dx is equal to 1 upon 2 in bracket 1 plus x square. So in this way we find a solution for u. Now we consider the second function, that is v, equal to tan inverse in bracket 2x into root 1 minus x square, whole thing divided by 1 minus 2x square. Now in this form we put x is equal to sine theta. Therefore, theta must give sine inverse of x. So the next step will be v is equal to tan inverse in bracket. Now whenever x, we have to write sine theta. So we get 2 sine theta into root 1 minus sine square theta, whole thing divided by 1 minus 2 sine square theta, bracket complete. Therefore v is equal to tan inverse in bracket 2 sine theta, we write as it is. Now square root of 1 minus sine square theta, that gives cos square theta, and square root cancel. So finally we get cos theta. Whole thing divided by, we write 1 minus 2 sine square theta as it is in the denominator. So finally we get v is equal to tan inverse in bracket. Now numerator is 2 sine theta cos theta, which is nothing but formula of sine 2 theta. And in the denominator 1 minus 2 sine square theta, which is also formula of cos 2 theta. Therefore, V is equal to tan inverse. Now sin theta upon cos theta. So here we get tan of 2 theta. Cancelling tan and tan inverse. So we have V is equal to 2 theta. Now for theta, we write sin inverse of x. So V is equal to 2 into sin inverse of x. Now differentiate V with respect to x, we get so the next step will be dv upon dx is equal to 2 as it is, derivative of sin inverse is under root 1 minus x square. So in this way we get dv upon dx is equal to 2 upon root 1 minus x square. Now we use theorem which is based on parametric function, that is du upon dv can be written as du upon dx upon dv upon dx. Therefore, du upon dv is equal to du upon dx upon dv upon dx, provided that dv upon dx is not equal to 0. The next step will be du upon dv is equal to. Now for du by dx we substitute that 1 upon 2 in bracket 1 plus x square. Whole thing divided by, for dv by dx we substitute 2 upon under root 1 minus x square. Therefore, du upon dv is equal to 1 upon 2 in bracket 1 plus x square into root 1 minus x square upon 2. So therefore du upon dv is equal to square root of 1 minus x square upon 2 into 2 4 in bracket 1 plus x square in the denominator. But in a question we have to find du by dv at x equal to 0. Therefore du upon dv at x equal to 0 is equal to, now whenever x we have to substitute 0, so we have under root 1 minus 0 square upon 4 in bracket 1 plus 0 square. On simplifying, square root of 1 minus 0 square, that is square root of 1 means 1, and in the denominator 1 plus 0 square we get 1, and that multiply by 4, so we get 4. So in this way du upon dv at x equal to 0 gives us the answer 1 upon 4. So this is a required solution for the given problem. Thank you.